within subject's design. So each participant gives you a dependent variable in all three of your conditions. So you get 3 DV measures from each participant. Everything else is the same. The null is that your 3 population means are the same. The effect size interpretations are the same. What the F statistic tells you is the same. How you enter your data is very similar to repeated measures t-test or within subjects t-test, paired samples t-test. All these names don't really matter as long as you're doing the right thing. But you can see you have 1 row per participant. We have 3 participants. Each participant gave us 3 aggression scores. The aggression score when they were in the angry condition, their aggression score in the neutral, their aggression score in the happy. So each column is a mixture of one condition level and the DV at that condition level. So in the angry condition, aggression scores. In the neutral condition, aggression scores. In the happy condition, aggression scores. 1 row per participant. This can be nominal or ID. It can be whatever. This is continuous, continuous, and continuous. We click our ANOVA. We click repeated measures. We go up here. We'll see this. We might have to click up to it like I did. We have to give it a name. Emotion. Anger. Neutral. Happy. All I did was type and hit enter. You can see here, anger, neutral, happy. Anger goes here. Neutral goes there. Happy goes there. You will not fill these out for one-way ANOVA. We would like eta squared. There are other options you can click, not in the model or assumptions check. In your post-hoc test, we want a post-hoc for emotion. We might as well get our p-values. We definitely want our estimated marginal means for emotion has a plot and has a table. You can throw your observed scores on your table, and you can click group summaries to see what we got here. Let's see what our results say. From here, what do we care about? Our p-value. It's significant. Our eta squared, that's our sample effect size. We don't have the 90% confidence interval. We're going to have to get that next. Those are the 2 things we care about. They're right there. This suggests there's a significant difference among our 3 population means. We don't know where it is. Our post-hoc tests are down here. And you have your P correct, you have your uncorrected P, your Tukey's P, your Bonferroni's P. And you should use Tukey or Bonferroni when you're reporting. However, you're going to see an issue. The issue is that we do not have the 95% confidence interval of our post-hoc follow-ups. You're going to have to find those. I'm going to talk about that in a second because I'm just going down what the output is. This is our estimated marginal means. You spend time on this. I can see that those in the anger condition were more aggressive than those in the neutral, who were more aggressive than those in the happiness condition. I have to look at my post-hoc test to figure out, which groups are different, from which population means are different from which other population means. Our group summary told us nothing. That wasn't important, but I just was curious. It's just telling us sample size. No big deal. Our estimated marginal means, these are just our means and standard errors. Those will come in useful when making graphs. So what don't we have? We don't have our 90% confidence interval of eta squared. We don't have our 95% confidence interval of Cohen's D's for our follow-up tests. So I'm going to have to go to another program to get 90% confidence intervals of eta squared. But for this test, I'm going to just go ahead and do a whole bunch of paired samples t-tests to get my 95% confidence intervals of effect size. So I'm going to go ahead and just kind of scroll, get that out of the way and show you I did 1 post-hoc test so far. Anger versus neutral. We can see the p-value, the effect size, 95% confidence interval of effect size. I'm going to click on this again. I want anger versus happy, and I want neutral versus happy as well. So when you have to do multiple tests, you can go ahead and do them all at the same time. So our 95% confidence interval for anger versus neutral is a Cohen's d of negative 0.4 to positive 2. Because I put them in what I expected to be highest and lowest, my signs match my predictions. So the true effect could be in the opposite direction from what I predict, a small effect, to a large effect in the direction I predicted, anything in between. For anger versus happy, we get a better result here, okay? The 95 CI, which is, I'm not looking at the other stuff, I just need the 95 CI. That is from a small effect in the direction I predicted to a large effect. Now you're like, oh, this aggression neutral versus aggression happy, which is all that's being compared there, is just how it works. I know it's a little weird and ugly to read. But essentially, that one didn't calculate because if you look at the data, neutral minus happy, 3 minus 1 is 2, 4 minus 2 is 2, 3 minus 1 is 2. The actual t-test, when the computer does it, runs the t-test on those difference scores. There's no variation. You're not getting an output. That is a rare case due to the fact that I'm using basic data to help us out. So you will never see this in your own report, but it came up because there is no variation in our difference scores that are being compared. Don't worry about that point. I'm just telling you this is because I used bad data. We will be running more data than this in our actual experiments and, in the real life. This just happened with this data set. The other thing we don't have is the non-parametric test, which is super easy to get. Non-parametric, repeated measures. We click in here. The only thing I care about is this overall p-value. I want you to see that. That's our new non-parametric test. This is non-significant. By our rules, there's some violation of assumptions going on that's likely driving our significant result, even though this is really close, right? We do know we need to run more participants in general. This is a sign. This is doing what it's supposed to do. These non-parametric tests are telling us our data are kind of bad, which we know when we're putting them in. This whole series is about getting our outputs, not having good data. We need one more thing, the 90% confidence interval of eta squared.